Hello, welcome to Electronics Education. This is Vincent Chang. In the previous video, we talked about the feedback structure, which was quite easy. But now we are moving forward to, let's see, a feedback topologies. There are 4 topologies, so it gets a little bit complicated. So feedback part 2. 4 topologies. Let's start with the ideal feedback structure. And this is quite easy. You can study this. You don't need me for this, right? So you can understand this by yourself. The relationship between open loop gain A and the closed loop gain AF. The real deal lies on the 2 assumptions. Remember, there are 2 assumptions embedded in the ideal feedback structure. The assumption number 1, the open loop gain A is independent of source, load, and also feedback network. The assumption number 2, both network, open loop gain A, amplifier, and feedback network are unilateral. Now let's move on to the feedback topology. Gets a little bit complicated. On the left-hand side is the mixer. It's a mixer between what? Between external source signal and also the feedback signal. It's a mixer. On the right-hand side, it's called sampling. It's a sampling network. So there's a mixer on the left-hand side, the behavior of mixing, and also the behavior of sampling. And the relationship to describe the mixing is SS minus SF equals SI. 2 types of mixing. A series mixing and also shunt mixing. Series mixing is for the voltage signal. S now becomes the V. So VI equals VS minus VF. But the shunt mixing dedicates to the current signal. So IS minus IF equals II. On the right-hand side, for the shunt sampling is the voltage sampling. You sample output voltage. But for the series sampling, you sample current. Let me repeat that. For voltage sampling, sample what? Is the shunt sampling. But what about the left-hand side? For the shunt mixing, it's the current mixing. You want to go back? For shunt mixing on the left-hand side is the current mixing. But the shunt sampling on the right-hand side is the voltage. All right? Okay? So make sure you get this. So 4 topology, 2 times 2 becomes 4. The first topology is called Series-Shunt feedback. So which is the voltage mixing and then voltage sampling. So voltage in, voltage out. The second is called Shunt-Series feedback. It's the current mixing and then current sampling. The current in and then current out. The current amplifier. The third type is called Series feedback. The series mixing and then series sampling. Series mixing and then series sampling. Last one is called Shunt-Shunt, which is current mixing and then voltage sampling. All right? So 4 topologies of feedback. 4 feedback topology. The first one, ideal. Remember, what do I mean by ideal? 2 assumptions. That's the real deal that you need to remember. All right? The 2 fundamental assumptions associated with the ideal feedback structure. So the 2 fundamental assumptions we talked about in the previous lecture remain the same, still valid when I talk about the ideal feedback. So ideal series-shunt feedback, the voltage mixing and then voltage sampling. The voltage mixing and then voltage sampling, voltage amplifier. The nature of the amplifier, the blue part is voltage amplify. Voltage in and then voltage out. So what about this one? For the shunt series feedback, the previous one is series shunt. This one is shunt series. For the shunt series, so current in, then current out. What type of amplifier? Current amplifier. It's the current amplifier. Now here comes the third part. The series feedback, which means the voltage in and then current out. So think about this. The current divided by voltage, which means the conductance. But it's the output current divided by the input voltage. So there's a meaning of what? The transfer. So it's the transconductance. So transconductance amplifier. So the nature of the amplifier, the blue part, belongs to a transconductance amplifier. The last one, for the shunt feedback, it's the current input and then voltage out. The output voltage divided by the input current. So voltage divided by current is the resistance, but it's the output voltage there divided by the input current here. So there's a meaning of what? The transfer. So it's the transresistance amplifier. Transresistance amplifier. So I think, are you with me? It's very clear, right? It's getting clear. So here's the takeaway. For the voltage amplifier, I'm going kind of, another way. All right? For the voltage amplifier, what type of feedback? I'm testing you. For voltage amplifier, a voltage feedback amplifier, what types of feedback needed? Is associated with what? Series shunt. It's the series shunt feedback. What about current amplifier? The second takeaway. It's the opposite, right? So it's the mixing. It's the shunt mixing and then series sampling. So shunt series feedback. It's the shunt series feedback. So pay attention. The slide, right? The symbol is all change accordingly. The previous one is, the previous one is VS, VF, VI, VO. And then this one is IS, IF, II, IO. All right? They all change accordingly. Right? So it's the shunt series feedback. What about this one? Transconductance amplifier. Now, the 3V on the left, the 1I on the right. So transconductance. So it's a series feedback. It's the series feedback. The last one. What about the transresistance amplifier? The transresistance amplifier. For the transresistance amplifier, you need the current input and then voltage output. So for the current input, what type of mixing? Shunt mixing and shunt sampling. So shunt feedback. So we have come to the end of this lecture video. Thanks for watching.